Hi everyone. Today we will have a philosophical discussion about artificial intelligence. While the development of AI is often framed as a problem of engineering and data scale, a deeper understanding of its capabilities and inherent limitations may benefit from a philosophical perspective. Specifically, we will explore AI through the framework developed by the 18th century philosopher Immanuel Kant.
A dominant paradigm in AI research suggests that with sufficient data, intelligence will emerge. This is a fundamentally empiricist view. Kant, however, argued against pure empiricism. This quote from his Critique of Pure Reason captures the essence of his counterargument. It translates to, "Thoughts without content are empty. Intuitions without concepts are blind." For Kant, knowledge requires two components. First, intuitions, which we can think of as sensory input or raw data. Second, concepts, which are the pre-existing cognitive structures or rules needed to organize that data. Neither component is sufficient on its own. This synthesis of data and structure forms the foundation of our analysis today.
So, if we accept that data functions as Kantian intuition, we must then ask about the nature of that data. This brings us to a foundational distinction in Kant's philosophy: the separation between the world as it is perceived and the world as it might exist in itself, independent of any observer.
Kant posited that we never perceive reality directly. Instead, our cognitive faculties actively structure our experience. The world we have access to, what he termed the phenomenal world, is a representation. The underlying reality, which he called the noumenal world, or the thing in itself, remains fundamentally inaccessible to us.
This distinction maps directly onto the operation of a deep learning model. A model never observes the complete, true data-generating process of the world. It is exposed only to its training data, a finite and potentially biased sample. This data set constitutes the model's entire phenomenal world. The true underlying reality that generates all possible data is, for the model, the inaccessible noumenon.
This philosophical distinction provides an explanatory framework for several well-documented technical challenges in AI. Out-of-distribution failure, for instance, occurs when a model encounters data from outside the scope of its phenomenal training set. Adversarial attacks often succeed by creating inputs that exploit discrepancies between the model's learned representation and the underlying reality. Similarly, inherent bias arises when the training data itself is a skewed representation, causing the model to codify those biases as fundamental properties of its world. If experience is shaped by pre-existing cognitive structures, what are the equivalents of these structures in an artificial neural network? We can map Kant's model of the mind onto the architectural priors that define modern deep learning systems.
Let's begin with Kant's most fundamental structures, the forms of intuition, which are space and time. He argued these are necessary preconditions for any experience. We observe an analog in AI architectures. Convolutional neural networks, or CNNs, are designed with a built-in inductive bias for spatial locality, effectively functioning as a form of space. Transformer models, on the other hand, are architected to process sequential data, providing them with a form of time. Kant then described the categories of understanding, fundamental concepts like causality and unity that the mind uses to structure intuitions. The AI analog can be found in a network's core components, its layer types, its activation functions, its normalization schemes. These are the basic operations the model can perform to organize its input. Finally, Kant's schematism describes how abstract concepts are applied to sensory data. A compelling parallel in AI is the attention mechanism, which dynamically determines how different parts of an input sequence relate to one another, mediating between raw data and higher-level representations.
This brings us to the process of learning. Kant argued that knowledge is not passively received, but actively constructed. He termed this process synthetic a priori judgment, signifying the creation of new knowledge that is not derived purely from experience, but from applying pre-existing mental structures to that experience. Within this Kantian framework, model training is not merely pattern recognition. It is an active process of synthesis, where the model constructs a complex function, a representation of new knowledge about its phenomenal world. This synthetic process can be observed directly in the training loop. We begin with the a priori structures, the model's architecture and the loss function, which are defined prior to data exposure. Then come the intuitions in the form of the training data. The optimization algorithm, typically gradient descent, serves as the engine that systematically applies the a priori rules to the data. The output is the synthesized knowledge itself, the trained model's weight matrix. The primary measure of success for this synthesis is generalization. A model that has only memorized its training data has failed to synthesize knowledge. Effective learning is demonstrated by the ability to apply the constructed rules to novel instances. This capacity is highly dependent on the quality of the model's inductive biases, the specific choices made in its a priori architecture.
To explore the limits of this process, we turn to another of Kant's critical distinctions, that between two cognitive faculties. First is Verstand, or understanding, which is the faculty of rules and concepts used to structure experience. Second is Vernunft, or reason, which is the faculty that seeks ultimate, unconditioned principles and strives for systematic unity, often by moving beyond direct experience.
Using this distinction, current AI systems can be described as highly potent implementations of Verstand. They excel at applying learned rules to data for tasks like classification and regression. However, they appear to lack the faculty of Vernunft. This absence may explain their well-known deficiencies in domains that require abstract reasoning beyond pattern matching. These limitations are not trivial. AI models are proficient at identifying correlations in data, but struggle to infer genuine causality. They have difficulty with abstract reasoning that is not grounded in their training distribution, and critically, they lack moral autonomy, a capacity that Kant argued is intrinsically linked to the faculty of reason. Current AI, therefore, possesses a powerful form of understanding, but does not demonstrate reason.
This Kantian analysis suggests a direction for the field. Kant's critique of pure reason was a project to delineate the conditions and limits of human knowledge. AI research might similarly benefit from its own critical project, to systematically investigate the conditions and limits of knowledge in artificial systems. Such a project is, in some ways, already underway. The field of explainable AI, or XAI, can be viewed as an attempt at what Kant called a transcendental deduction, a justification for how a system's knowledge is possible given its structure. The discipline of AI safety and alignment is fundamentally concerned with defining the legitimate bounds of an AI's application, analogous to Kant's project of preventing reason from making claims beyond the limits of possible experience.
In sum, this philosophical lens challenges purely empiricist views of artificial intelligence. It suggests that any knowing subject, whether biological or artificial, must operate under similar constraints. These include the necessity of a priori structures, the mediated nature of input, and a constructive, synthetic process for generating knowledge. Intelligence, from this perspective, is not merely discovered in data, it is constructed.
Kant's philosophy does not provide engineering solutions, but it offers a robust conceptual framework for analyzing the foundations of deep learning. It equips us with a set of critical questions to guide research toward more transparent, reliable, and responsibly deployed AI. The remaining question is whether the field is prepared to undertake a systematic critique of its own rational foundations.